This is lesson 2.4b, picking up with example 4 with the rational zeros theorem. It states, suppose f is a polynomial function of degree n is greater than or equal to 1 of the form that, with every coefficient an integer and a sub 0 is not equal to 0. If x equals p over q is a rational zero of f where p and q have no common integer factors other than 1, then the p comes from here and the q comes from here. What it is, this is what basically, because looking at it, it's just like, what? Actually q and then p. Yeah, the p's are the factors of a sub 0 and q is the factors of the 0. So p is going to come from the 1. So you're going to factor 1. The only factor of 1 is 1 times 1. Q is going to come from the front. So again, it's 1. So my only factors, my possible rational zeros, are plus or minus p over q. So it would be plus or minus 1, and that's it, because 1 over 1 is 1. And then you test them one by one. And this one we would have 4 to test, and we test it using synthetic division. And these problems can get really long. So I'm going to test 1 with 1, -3, 0, and 1. 1, 1, -2, -2, -2, -2, -1. So it works if you get a 0. I did not get a 0. So now I'm going to test -1. Make my pen smaller. 1, -3, 0, 1. 1, -1, -4, 4, 4, -4, -3. So it didn't work. And that's all. Oh, I only have 2 to do. Why did I say I had 4? I don't know. So this one has no rational zeros. Now if we graph this, x cubed minus 3x squared plus 1, x cubed minus 3x squared plus 1. I see that I have 3 real zeros. I have 3 places where it crosses the x-axis, here, here, and here. Those must all be irrational zeros because it has no rational zeros. And we don't have to find them. If it asked me to find all the real zeros, I would then go into my calculator and find the zeros. On this one, the p is all the factors of 2, and q is all the factors of 3. So the factors of 2 are 2 and 1. The factors of 3 are 3 and 1. And it's plus or minus p over q. So it's, let's see, let's start with 2. Plus or minus 2 over 3, plus or minus 2 over 1, plus or minus 1 over 3, plus or minus 1 over 1. I have to put all the p's over all the q's, and then I test them. It is always easiest to start with 1, and you have to test. You have 1, 2, 3, 4, 5, 6, 7, 8 choices here. When you have that many, this problem could take you an entire page. I am kind enough on the test, as far as the rational root theorem is concerned, all you have to be responsible for is listing the possible zeros. I'm not going to make you test them all. The problems where we have to do that, I'm going to say, if 1 is a 0, then find the other ones, or like that. I'm going to get you started, because I could give you a test and it'd take you 4 hours to finish it. So I always start with 1 because most often that's the answer that works, and on the AP test it's always either 1 or -1 if you have to use synthetic division. Why am I writing that out? I don't know. I apologize if you just wrote that. 3, 4, -5, -2. 3 times 1 is 3. 7 times 1 is 7. 2, 2, 0. Yay! So 1 is a factor. So x minus 1 is one of my factors because 1 is an answer. So then I take what's left. It'd be 3x squared plus 7x plus 2. It's a quadratic. I can solve a quadratic, so now I'm going to factor it. 7, 6, 6 and 1, 3x squared plus 6x plus 1x plus 2. 3x, x plus 2, plus 1, x plus 2, x plus 2, 3x plus 1. So my rationals, my factors, to factor it, I've got x minus 1 times x plus 2 times 3x plus 1 equals 0. So my answers are 1, negative 2, and negative 1/3. There's my answer. Okay. Example 5, it says use the factor theorem to determine whether the first polynomial is a factor of the second polynomial. The factor theorem is the one that says, whoops, still writing with a highlighter. The x would be 3, and you just fill it in. 3 cubed minus 3 squared minus 3 minus 15. And you tell me whether or not it works. Well, 3 cubed is 27, minus 9, minus 3, minus 15. 27 minus 9 is 18, minus 3, minus 15 is 15, minus 15 is 0. So is it a factor? Yes, because I got 0. Example 6, yep, you already did this in your homework, whoops. You would get x plus 1, x minus 3, and x plus 5. You would FOIL that out. And what I neglected to tell you before you already did these problems in your homework is that if the leading coefficient is 2, you just take your answer and multiply it by 2. And you can take a minute to try to FOIL these out. You can pause me if you want to, just to make sure you can do this problem. And when you FOIL it out, you're going to get, I guess I have to FOIL it out. I don't have an answer already on my paper. Crap. So it'd be x squared plus 5x minus 3x minus 15, which is x squared plus 2x minus 15. So it'd be x cubed plus 2x squared minus 15x plus 1x squared plus 2x minus 15. So that's x cubed plus 3x squared minus 13x minus 15. But I want a leading coefficient 2 and degree 3. Well, degree 3, check. Leading coefficient 2, no. Right now it's a 1. So if I multiply the entire thing by 2, which just stretches it vertically, it's not going to change the zeros, then I now have a polynomial function with leading coefficient 2. Using only algebraic methods, find the cubic function with the given table of values. What you would do here is, these are my zeros. So I would first say x plus 4, x minus 3, x minus 5. I would FOIL it out. X squared minus 5x minus 3x plus 15, x squared minus 8x plus 15, and then times x plus 4, x cubed minus 8x squared plus 15x plus 4x squared minus 32x plus 60, that's 8x cubed minus 4x squared minus 17x plus 60. Is that right? X cubed plus, yes. And then the other piece of the puzzle is that if I plug in a 0 where my x is, I get 180. Right now, if I plug in a 0 where my x is, I get 60. It's not big enough. It's not big enough by 3. So if I multiply the entire thing by 3, am I changing the zeros? No, I'm just stretching it vertically. Minus 12x squared minus, don't know that. 7 times 3 is 21, carry my 51. 51x plus 180. Now it matches the table. Yay. We skip that. Find all the real zeros. Okay, here we go. Find all the real zeros. So that's including any that aren't rational. So the first thing I would need to do, and this question's yucky, is find my P and my Q. Remember that your P comes from your 8, and your Q comes from your 2. So it's all the factors of 8. That's 1, 2, 4, and 8. All the whole numbers that will multiply to give you 8, and then 1 and 2. So it's plus or minus P over Q. So it's plus or minus 1 over 1, plus or minus 1 over 2, plus or minus 2 over 1, plus or minus 2 over 2, plus or minus 4 over 1, plus or minus 4 over 2, plus or minus 8 over 1, plus or minus 8 over 2. Now some of these are repeated. This one, that one are the same. So I could condense this list. It's be plus or minus 1, comma. Then I have 2 over 1, 4 over 2 are the same. So plus or minus 2. And then also plus or minus 4 over 1 and plus or minus 8 over 2 are the same. So that's plus or minus 4. And then plus or minus 1/2, plus or minus 8. I'm going to give you a hint, and I wouldn't give you this question without giving you a hint. We're going to start with 4. 4 works. And if you didn't have a clue, you would just start with 1 and work your way up to 4, and it would take you 1, 2, 3, 4, 5 times to get there if you just started with 1. So I'm going to tell you that 4 works. Usually I will give you the first one, or I'll give you the first and second one in this case. I'm going to tell you that 4 works. It says given 4 is a 0. So I would drop it down. 2 times 4 is 8. 1 times 4 is 4. Negative 4 times negative 4 is 16. Negative. Negative 2 times 4 is negative 8, and 0. And now I'm also going to tell you that negative 1/2 is an answer. If I didn't know that, I would have to check them all. I would have to do synthetic division 2, 4, 6, 8, 10 times before I could arrive at the proper answer. With the use of calculators, we don't need to do that anymore. I'm going to tell you that 1/2 is, or negative 1/2 is also an answer. So now I'm going to do negative 1/2 into what's left. And this isn't an answer anymore. So 2 times negative 1/2 is negative 1, with 0, 0, negative 4, 2, 0. And what I wind up with left is, this was a 4, so this is a cubed, and this is going to be a squared. 2x squared plus 0x minus 4. And I can solve this. I can set it equal to 0, and I can solve it. Add 4, 2x squared equals 4, divide by 2, divide by 2. Why did I set that equal to 0? Because I'm trying to find the zeros. So x equals plus or minus the square root of 2. So my answers are square root of 2, negative square root of 2, negative 1/2, and 4. And we just flat don't have time to test all those, and that's ridiculous. And we're not going to do 10. So that concludes this lesson.